Right, let's get this straight. For years we've been told the future is electric, a lovely idea of course. Quiet roads, no nasty fumes making the pigeons cough, and the satisfying whoosh as you pull away from the lights. But there have always been a few, shall we say, fiddly bits to the whole affair. The biggest one being the battery. It's the heart of the electric car, but it's been a bit of a temperamental one. Then, just when we were all getting used to the idea of planning our long journeys around service station coffee breaks, Toyota of all people, pops up and says they've cracked it. They've announced a breakthrough in something called solid-state battery technology, and it's not just a minor tweak, it's the sort of news that makes you spit out your tea. Toyota, you see, has always been the sensible one in the playground. While other car makers were making flashy electric supercars that could go from 0 to 60 in the time it takes to sneeze, Toyota was quietly perfecting its hybrids. They were playing the long game, it seems. This announcement isn't just about a slightly better battery, it's about a completely different kind of battery, one that promises to charge up, in the time it takes to buy a Ginster's pasty, travel for hundreds and hundreds of miles on that single charge, and not have a tendency to get a bit, well, fiery if you look at it the wrong way. This is potentially the biggest leap in car technology since we moved the engine from the back to the front. It's a proper game changer. The implications are, frankly, enormous. Imagine a world where range anxiety is a forgotten phrase, a relic of a bygone era, like choke knobs and cassette players. Think about electric cars that are not just for city-dwelling early adopters, but for everyone. For the family driving to Cornwall for the summer holidays, for the sales rep who covers half the country in a week, for the person living in a block of flats with nowhere to plug in overnight. Toyota's news hints at a future where owning an electric car is not just a green choice, but the most practical, simple, and logical choice for absolutely everyone. It's a bold claim, and one that has sent a rather large jolt through the entire automotive industry. So what we have here is not just another press release about a car that's 5% more efficient. This is a fundamental shift in the very chemistry that powers our mobility. It's the sort of thing that gets engineers all giddy and sends rival company executives into a bit of a flap. For the rest of us, it means the electric car dream might finally be ready to pull out of the slow lane and into the fast one. It's terrifically exciting, and it all hinges on this mysterious new piece of kit. It's time we had a proper look under the bonnet, so to speak, and figured out what on earth they've been cooking up in their Japanese laboratories. The future, it appears, is solid. Now don't worry, I'm not about to get all bogged down in advanced chemistry. I probably couldn't even if I wanted to. But to understand why this is such a big deal, we need to grasp the basics of what a solid-state battery actually is. Think of a regular battery, the kind in your phone or your current electric car. It's a bit like a cheese and pickle sandwich. You have two solid bits, the anode and cathode, which are like the bread, but in between them, you have a sloppy, liquidy bit, the electrolyte, which is the pickle. This liquid is what allows all the little electric particles, the ions, to slosh back and forth, creating the power. It works, but that liquid is the source of many of our problems. A solid-state battery, as the name rather brilliantly suggests, gets rid of the pickle. It replaces that wet, sloshy electrolyte with a solid material. It could be a sort of ceramic, a glass, or a polymer. A very clever, very thin, solid slice of stuff. So now, our battery sandwich is made of 3 solid layers. The little ions still have to wiggle their way from one side to the other to make the electricity flow, but they do it through this solid middle layer. Getting this to work has been the holy grail for battery scientists for decades. It's incredibly difficult to make a solid material that lets ions pass through it as easily as a liquid does, and that doesn't crack or fall apart after a few charges. The genius of what Toyota claims to have achieved is creating a solid electrolyte that just works. One that is stable, efficient, and can be manufactured properly. This isn't just a minor change, it's a complete reimagining of the battery's internal architecture. By making everything solid, the battery becomes much more compact and energy-dense. You can cram more power into the same amount of space, or you can have the same amount of power in a much smaller, lighter package. This is fantastic news for car designers, who are always fighting a battle against weight and size. A lighter car is a more efficient car, and a more nimble one too. So in essence, Toyota has taken the wobbly, precarious jam out of the donut and replaced it with a perfectly formed, highly efficient, solid filling. This solid nature is the key to everything. It's what unlocks all the potential benefits we're about to discuss, the lightning-fast charging, the epic range, and the fact it won't burst into flames if it gets a bit cross. It's a simple concept on the surface, moving from liquid to solid, but the engineering and scientific challenge behind it has been monumental. And solving it means the rule book for electric cars is about to be completely rewritten. Good riddance to sloppy pickle. To truly appreciate the new hotness, we must first understand the old and busted. Let's have a chat about the current champion, the lithium-ion battery. It's in your phone, your laptop, and every electric car on the road today. And to be fair, it's a remarkable piece of engineering. It has powered the portable electronics revolution and made electric cars possible in the first place. But, like a trusty old Labrador, it's getting on a bit and has some rather frustrating habits. Its biggest foible, as we touched on, is that liquid electrolyte. It's flammable stuff, a bit like petrol really. That's why you hear those rare but scary stories of phones or cars catching fire. The liquid inside these batteries is the main reason they are so bulky and heavy. To keep that volatile liquid safe, you need to surround it with all sorts of robust, heavy protective casings and complex cooling systems. It's like having to build a small fortress around your car's fuel tank, which adds a tremendous amount of weight and complexity to the vehicle. This weight is the enemy of performance and efficiency. It's why electric cars often feel so much heavier than their petrol-powered counterparts. All that heft has to be lugged around, which uses up precious energy and reduces how far you can go on a single charge. It's a constant compromise between power, safety, and weight. Then there's the charging speed. Pumping electricity into a lithium-ion battery is a delicate process. If you do it too quickly, you risk damaging the internal structure and, in a worst-case scenario, causing it to overheat and fail spectacularly. The battery's management system has to act like a very cautious pub landlord, carefully controlling the flow of electricity to keep everything stable. This is why it takes 30 minutes to get an 80% charge at a top-of-the-range rapid charger, and many hours from a plug at home. It's simply the physical limit of what the liquid-based chemistry can safely handle. It's a fundamental bottleneck that has held back the convenience of electric motoring. And finally, there's the range and lifespan. Over time, that liquid electrolyte degrades. Little spiky structures called dendrites can form inside the battery, a bit like rust, which reduce its capacity and can eventually cause a short circuit. This is why your phone battery doesn't hold its charge as well after a couple of years, and it's a major concern for electric car owners. A solid-state battery, by contrast, is far more resilient. Because its structure is solid and stable, it doesn't degrade in the same way. It can withstand many more charge and discharge cycles without losing significant capacity, meaning the battery could well outlast the car itself. It solves the safety, the charging, and the longevity problems in one fell swoop. Let's put all this technical talk into a real-world context. What does this actually mean for you, the driver? Well, let's start with the most tedious part of owning an electric car today, charging it on a long journey. You're driving from London to Edinburgh. With a current decent EV, you'll probably have to stop at least once, maybe twice. You pull into a service station, find a charger that's actually working, faff about with an app or a card, and then you wait. You'll be there for a good 30 to 45 minutes to get enough charge to continue. It's a perfect amount of time to get a lukewarm coffee and a stale sandwich, and to become deeply bored. Now imagine that same journey with a Toyota powered by one of these new solid-state batteries. Toyota is talking about a charging time of 10 minutes or less. Let that sink in. 10 minutes. That is roughly the same amount of time it takes to fill a petrol car with fuel, pay the cashier, and perhaps grab a packet of crisps. Your entire refueling routine is transformed from a long, drawn-out chore into a brief, incidental pause. A splash and dash for electrons. This single change completely eradicates the biggest practical objection to electric cars. The long-distance journey becomes as simple and spontaneous as it is with a petrol or diesel car. The other number being thrown around is the potential range. Initial reports suggest these batteries could power a car for over 700 miles, perhaps even up to 900 miles, on a single charge. Let's be conservative and say 750 miles. That's London to the northern tip of Scotland without stopping. That's Paris to Berlin with miles to spare. For the vast majority of people, that means you might only need to fill up once a week, or even less. The daily commute, the school run, the weekly shop. You do all of that for days on end without even thinking about the battery level. Range anxiety becomes a complete non-issue. This combination of massive range and lightning-fast charging creates a sense of freedom that today's electric cars simply can't offer. You wouldn't need to meticulously plan your route via charging stations anymore. You could just get in the car and drive, safe in the knowledge that if you do need to top up, it will be a quick and painless process. It removes the mental load of EV ownership. The car adapts to your life, not the other way around. This isn't just an improvement, it's a revolution in convenience. It makes the electric car not just an alternative but a superior proposition in every practical sense. It's all rather brilliant. It's interesting that this massive leap forward has come from Toyota. For the last decade, they've been seen as something of a laggard in the all-electric race. While companies like Tesla were making headlines with their bold EVs, Toyota seemed almost stubbornly focused on its hybrid technology. People in the know, journalists and industry experts, sometimes accuse them of being behind the times, of missing the boat on the electric revolution. They were the tortoise, plodding along with their tried-and-tested Prius, while the electric hares raced ahead. But it turns out the tortoise wasn't asleep, it was just being incredibly methodical. Toyota has a corporate culture that is famously, almost painfully, cautious. They have a philosophy called Kaizen, which means continuous improvement, and another called Genchi Genbutsu, which means go and see for yourself. This all boils down to an obsession with quality, reliability, and not releasing a product until it is absolutely, unequivocally ready. They would rather be 5 years late with a perfect product than 1 year early with something that has flaws. This is why Toyotas have a legendary, if slightly boring, reputation for never breaking down. They test things to destruction, and then they test them again. This philosophy explains their approach to electric vehicles. They saw the limitations and potential dangers of the early lithium-ion batteries. They understood the challenges of creating a charging infrastructure and the problem of battery degradation over time. So instead of rushing a fully electric car to market, they invested billions of pounds and thousands of researchers into perfecting the next generation of battery technology behind the scenes. They were playing a much longer game than anyone realized. They weren't trying to win the first lap. They were positioning themselves to win the entire race, decisively. It's a classic tortoise strategy, and it appears to be on the verge of a spectacular payoff. This reputation for reliability is going to be a huge asset when they finally launch these solid-state cars. People trust the Toyota badge. They know that if Toyota says a battery will last for 15 years and charge in 10 minutes, it will do exactly that, probably for 20 years. This isn't a flashy tech startup making bold promises. This is one of the world's largest and most respected engineering companies putting its entire reputation on the line. It gives their claims a weight and credibility that is hard to ignore. While the hares were grabbing the headlines, the tortoise was quietly building the future. And as the old story goes, we all know who wins in the end. Of course, Toyota isn't the only company in this race. The prize for creating the perfect battery is so enormous that every major car manufacturer and a whole host of tech companies are desperately trying to get there first. Tesla, for instance, has been the poster child for the electric car revolution. Their approach has been very different to Toyota's. They focused on optimizing the existing lithium-ion technology, building their own gigafactories to produce them at massive scale and creating their own superb charging network. They made EVs cool and desirable, and for that, they deserve a huge amount of credit. But they are still, for now, working with the liquid pickle battery. Then you have other giants like Samsung SDI and LG Chem who are battery specialists that supply many of the world's car makers. They are also investing heavily in solid-state research, as are a number of ambitious startups, some of which have emerged from university labs. Volkswagen, General Motors, Ford, they all have partnerships and research programs dedicated to cracking this nut. The entire industry knows that solid-state is the end game, the destination everyone wants to reach. The competition is fierce, a global technological arms race with trillions of dollars at stake. Everyone is working on a solution. So what makes Toyota's announcement so different? Two things really. The first is the sheer scale of their progress. While many others are still at the laboratory stage, showing off small prototype cells, Toyota is talking about overcoming the key manufacturing hurdles and preparing for mass production. They claim to have simplified the production process, which has always been a major stumbling block for solid-state tech, potentially making it cheaper and faster to build than current batteries. This suggests they are much further down the road to commercialization than their rivals. They've moved from the science lab to the factory floor. The second factor is Toyota's deep manufacturing expertise. It's one thing to invent a clever battery in a lab. It's another thing entirely to produce millions of them, reliably and affordably, and integrate them into a car. This is Toyota's bread and butter. They are masters of mass production at the highest quality. While a tech company like Tesla had to learn how to build cars from scratch, Toyota has been perfecting the art for nearly a century. This gives them a colossal advantage. They have the know-how, the factories, and the supply chains to turn this breakthrough into a reality for millions of drivers, potentially leaving their rivals scrambling to catch up. The ripples from this battery revolution will spread far beyond our roads and driveways. A cheap, safe, light, and incredibly powerful energy storage device is one of the most transformative technologies imaginable. Think about our homes. With batteries like these, we could easily store solar power generated during the day to power our houses through the night. This would make homes truly energy independent, slashing electricity bills and reducing the strain on the national grid. A whole neighborhood could effectively become its own mini power station, sharing and storing clean energy. It's a fundamental change to how we consume and manage power. Then consider the world of work and industry. This technology could create entirely new industries and countless jobs. We'll need people to manufacture the batteries, to build the new generation of cars, to install and maintain home energy storage systems, and to develop the software that manages it all. It could spark a manufacturing renaissance in countries that embrace the technology. Furthermore, industries that rely on heavy machinery, like construction and agriculture, could finally go electric. Imagine silent, zero-emission diggers and tractors, powered by quick-swapping solid-state battery packs. The air in our cities and countryside would become cleaner and quieter. From an environmental perspective, this is a monumental step forward. The biggest obstacle to a fully renewable energy grid is the intermittency of wind and solar power. The sun doesn't always shine, and the wind doesn't always blow, but with large-scale solid-state battery storage, we can save up the energy when it's plentiful and release it when it's needed. This smooths out the peaks and troughs, making a 100% renewable grid a practical reality. It would accelerate the transition away from fossil fuels like nothing else. And because these batteries are potentially longer lasting and use fewer problematic materials, their environmental life cycle could be far superior to current technologies. And it doesn't stop there. Think of electric airplanes for short-haul flights, silent and clean. Think of massive cargo ships crossing the oceans without burning tons of dirty bunker fuel. Think of medical devices with batteries that last for decades without needing replacement. This isn't just about making cars better. It's about a fundamental building block for a cleaner, more efficient, and more sustainable technological society. What Toyota has kickstarted is a chain reaction that could redefine the 21st century in the same way that the steam engine or the microchip defined their eras. It's that big. So after all this talk of ions, electrolytes, and global competition, what's the simple takeaway? It is this: the car in your driveway is on the cusp of the biggest change in its history. The solid-state battery promises to erase every single compromise currently associated with electric cars. The fear of running out of power, the tedious waiting at chargers, the worries about battery life, and the high purchase price, all of these could soon be things of the past. The electric car is about to grow up and fulfill its potential. It's on the verge of becoming, without any doubt, the best kind of car for everyone. This change will creep up on us, and then it will feel like it happened all at once. At first, it will be a new top-of-the-range Toyota, but soon, the technology will become cheaper and will filter down to every type of vehicle, from small city runabouts to family SUVs and white vans. Choosing an electric car will no longer be a statement. It will simply be the sensible, logical thing to do. It will be cheaper to run, more convenient to refuel, quieter, faster, and better for the planet. The grumble of the internal combustion engine, a sound that has defined our towns and cities for a century, will begin to fade away. Think about how your own life might change. Would you take more spontaneous weekend trips if you knew you could drive 500 miles and refuel in 10 minutes? Would you be more inclined to switch to electric if you knew the battery would last for 20 years and could even power your house during a blackout? This isn't science fiction. This is the practical, tangible reality that Toyota's breakthrough is promising to deliver within the next few years. It's a future where our personal mobility is cleaner, easier, and more liberating than ever before. It's a genuinely exciting prospect. The road ahead is still long, of course. There will be manufacturing challenges and intense competition, but a corner has been turned. The direction of travel is clear. The question is no longer if the electric car will conquer the world, but how quickly. Toyota's solid-state revolution has just put a very large foot on the accelerator. So the next time you're stuck at a petrol pump, inhaling fumes and watching the numbers on the screen climb at an alarming rate, have a little think. The replacement for that whole messy business is coming, and by all accounts it's going to be absolutely brilliant.